welcome to lesson 2 in our first unit of math. Today we're going to talk about geometric patterns and relationships in patterns. So geometric patterns continue on indefinitely in any type of pattern. We often refer to these as matchstick patterns or matchstick problems because we can construct them from matchsticks. So if you look here, each of these would be considered a matchstick or a toothpick. So for this pattern here, we may wish to know how many matchsticks are necessary to create a future diagram. For example, the 10th figure. So this would be the first figure, this would be the second figure, this would be the third figure. So how many toothpicks would it take to create the 10th figure? We may also wish to establish a rule or a formula which will tell us how many matchsticks there are in a figure further along the pattern. Now that rule and formula should work so that no matter which pattern you want to find the answer for, it would work for every single one. So suppose that the figure number, so which figure this is, so this would be figure number 1, figure number 2, and figure number 3, is n. So that's the unknown number. So that is our variable. And the number of matches needed to create that figure we would call big M. So in this, figure n is 1, and the number of matches for the big M would be 4. 1, 2, 3, 4. So from the first 4 figures in the pattern, we can create a summary table. So our figure number, again, is n. So our first figure here has 4 matchsticks. Our second figure has 7 matchsticks. Our third figure has 10 matchsticks, and our fourth figure has 13 matchsticks. So each time the figure number increases by 1, 1, 2, 3, 4, the number of matches, M, increases by 3. So from 4 to 7 is 3, 7 to 10 is 3, and 10 to 13 is 3. So by using the product notation, and product notation we use to make our expressions simpler, we agree to omit the multiple sign whenever possible and write our numbers in products before the variables. So M then, this number here, equals 3n plus 1. And what does that mean exactly? To help understand how this formula relates to the pattern, we can construct a more detailed table. So here's our figure number 1. Here's our figure, 4 matchsticks. How do we know that it's 3 times one figure plus 1? Well, we know it goes up by 3s. So that means we're only adding 3 matchsticks every time. So that means this green one over here has to be an extra. So that's your plus 1. So here's our 3 that we add, plus 1 to get 4. So here's our initial 3. We add 3 more, plus 1. So now we have 2 figures times 3 plus 1 is 7. 3 times 3 is 9, plus 1 is 10. And 4 times 3 is 12, plus 1 gives us our 13. So we can use this pattern to predict that our 10th figure then would be 10 times 3, which is 30, plus 1, which is 31. So we would know that our 10th figure over here would have 31 matches in it. We could do the same thing for the 100th figure. 100 times 3 is 300, plus 1 is 301 matches. So if we go back and look at this one, we would say the same thing. So here we've got figure 1 is 1, 2, 3 matches. Okay, figure 2, 1, 2, 3, 4, 5 matches. So we're going from 3 to 5. So this time we're increasing by 2. So that means this has to be 2 plus 1. 2, 2 plus 1. 1, 2, 1, 2, 1, 2 plus 1. Okay, so this would be 1, 3, 2, 5, 3, 7. So what would our formula here be? See if you can figure it out. We can also take this to another level and use a number crunching machine. And we've already talked a little bit about input-output tables in class, but we'll leave that for next class. We'll work just with our geometric patterns next time. So come to class, see if you can figure out what the pattern for this one would be, or the rule or the formula as you will, and we'll talk more about this and do some practice at this next class.